Okay, I wanted to give you the notes for this section 4.5 material, and as you can see, the title of this section is called 2x2 matrices, and we're going to be finding determinants of those 2x2 matrices, and we're also going to be finding inverses. The reason for these is because eventually, as we get to the end of this lesson, we're going to need to solve matrix equations that involve multiplication of two matrices. And so that's where we're heading. We're going to start with the basics, and we're going to keep building on this information until we get to the end of this lesson, and we'll be able to solve some more sophisticated matrix equations. So that's one of the reasons, that is our reason for knowing how to find the determinant of a 2x2. It's really pretty easy. In general, I've provided this for you. If you have this 2x2 matrix that I've identified here as A, B, C, D, the elements, then you just think about cross multiplication. You're going to multiply the A and the D numbers together first, and then you'll multiply the B and the C numbers, as I've indicated here. This is like your little formula. And then this always confuses some people because we've just left matrix multiplication, and we remember with matrix multiplication we always add products together. Well, with finding the determinant, you're going to subtract the product of AD, and from that you're going to subtract BC. And I've just given this little hint here maybe to help you remember. Just think of the D in determinant and the D in difference. Maybe that will help you remember that whenever you find the determinant, you're going to be subtracting. Okay, so let's do a few to practice. So our instructions here are to evaluate each determinant. So this is really pretty easy. I'm going to cross multiply. So let me just label this first one anyway. Remember, this was our number A, this was B, C, and D. So I'm going to cross multiply the A times the D number, that's negative 63, minus, remember we always subtract, and then multiplying the B and C numbers together, that's negative 40. So I guess the thing you really have to be careful with that causes some people a little bit of trouble is when you subtract a negative number. Remember, you're really adding here. So negative 63 plus 40 is negative 23. So that would be my answer for this problem 1A. Okay, just another practice problem. For 1B, I would multiply the A times the D number. 4 times 6 is 24. Minus, and then I'm multiplying the B and the C numbers together. That's negative 15. And again, I'm subtracting a negative number, so that's really addition. And I get my answer here as 39. Okay? All right, now that we know how to find determinants, we're going to take another step, and we're going to find the inverse matrix. Let me just give you a preview of where we're going, and maybe this will help you understand why we're finding the inverse. This equation that I'm about to write doesn't really apply to matrices, but I just want to use it as an example because this is something that you're already familiar with. I just want to show you, make a connection to some material that we already know about. Okay, what if I ask you to solve this equation, 2/3 x equals 30? Well, to get x isolated, to undo multiplying by 2/3, you would multiply by the inverse of 2/3, or sometimes we use the word reciprocal. The reciprocal, or the inverse of 2/3, is 3/2. Okay, and you would need to do that on both sides. All right, and we'll just go ahead and finish this little problem. We would solve for x, and that would be 90 over 2, which is 45. That's pretty simple. We just had to know to multiply by the inverse on both sides of the equation. Well, in the matrix equations that we're about to do, we're going to need to multiply by an inverse matrix in order to solve the equation. So before we can multiply by the inverse, we need to know how to find the inverse. And this is going to take some practice. It's something that you've probably never done before. Here's a very important note that I've provided for you. There are some matrices that do not have inverses. Okay, so one way of saying that is if a matrix has a determinant of 0, then that matrix does not have an inverse. Or the way I've phrased it here, if the determinant is not 0, then we do have an inverse. Okay, and I think in just a minute you'll see why a matrix does not have an inverse if the determinant is 0. And I'll point that out to you. All right, so here's my matrix A that I've provided. And if I want to find the inverse of matrix A, and I've provided you with a notation, because you're going to see this again probably in future math classes. My little notation there reads the inverse of A. When you see that, it looks like an exponent of -1. Anytime you see that notation referring to matrices or inverse functions that we'll get to later, that just reads the inverse of A. Okay, well, this is like our just using variables. This would be the definition, or maybe you want to think of it as the formula for finding an inverse. And we'll practice some of this, but notice, first of all, I need to find the determinant, because this tells me, I'll just mark this. This says that I'm going to be doing 1 divided by the determinant. Okay, so this takes us back to the reason why the determinant can't be 0. If the determinant is 0, then I'm going to be dividing by 0, and that's not possible. So that just follows up on our reasoning why the matrix has to have a determinant that is not 0. All right, so just to read through this, to find the inverse, I'm going to do 1 divided by the determinant, and whatever that number is will be multiplied. And notice how inside the matrix I changed the terms or the elements in matrix A. Notice what happened. The A and the D terms or elements, they switched places. And the other two elements, they changed signs. They just became opposites. They stayed where they are, but we changed them to their opposite sign. Okay, so A and D are going to switch places before we multiply by 1 over the determinant, and the B, C elements are going to become opposites of what they were originally. Okay, so that just kind of explains it. Well, now let's practice it. Here's my first example. Here I have this matrix E, and my directions are to find the inverse, if it exists. Okay, well, let's see if it exists. That means we need to find the determinant first. Remember how we found the determinant? We do a little cross multiplication, -2 times -7, minus, and then we cross multiply this way, 3 times 4 is 12, and the determinant is not 0. So I know that it does exist. We do have an inverse for this matrix. So here's how I find it. Going back to my previous slide, I do 1 divided by the determinant, which is 2, times. Okay, this is where I'm going to rearrange this original matrix E before I multiply by 1/2. I'm going to change places with the elements A and D. And then I'm going to change the signs of the elements B and C. And now I just do scalar multiplication. Remember, we covered that a few sections ago. I'm going to multiply 1/2 times each of these elements. And -7/2. This is just going to be -2, -3/2, and -1. this matrix is my inverse. Or you could, since we started off with matrix E, you could say that this is the inverse of E using our notation. All right, so that's how we find inverses. And you're going to be practicing some of this on the homework tonight. Let's try this one. We first find the determinant because this matrix may not have an inverse. So 3 times 6, 18, minus 2 times 9, 18. The determinant is 0. So there's no reason to go any further. This matrix has no inverse. Okay, so that's how we would express the answer. Okay, now we're to the real reason why we learned about determinants and how to find the inverses of 2 by 2 matrices. It's because we need to be able to use these skills to solve matrix equations. Do you remember my example earlier when we solved for x? I believe I had 2/3 x equals 30, and I multiplied by the inverse of 2/3 on both sides to solve for x. Well, in much the same way, I need to multiply by the inverse matrix on the left side of the equation. I'll just point it out to you this way. Because that matrix is being multiplied times x. So I need to undo multiplying by that matrix. And I'm going to do that by using the inverse of this matrix. All right, so let's find the inverse of the matrix on the left. And remember, that starts off with finding the determinant. So I'm going to multiply 3 times -5, -15, minus 4 times -4, which is -16. So the determinant is 1. Okay, well, I know that an inverse exists, so here's how I find it. I'll just change my colors up a little bit. Okay, so 1 divided by the determinant times, remember, before I multiply, I'm going to change the elements in this original. So I'm going to switch places with A and D. And I'm going to change the signs of B and C. So -4 becomes positive, and this +4 becomes negative. Well, I'm multiplying essentially by 1, which makes this pretty easy. So here is the inverse. -5, 4, -4, 3. Okay, now remember, when we find the inverse, we need to multiply by the inverse on both sides. Well, I'm just going to have you find the inverse, and then instead of showing multiplying by the inverse on both sides, I just want you to multiply it times this matrix on the right. Okay, because the result of multiplying by this inverse matrix on the left side is just going to give us x. That's the reason for multiplying by the inverse. So what I want you to do is find the inverse and then show multiplication times this matrix on the right side. And this is why we learned matrix multiplication yesterday. Here's a very important point that I need to make. The order of these two matrices is very important. When you're multiplying by the inverse times the matrix that already exists on the right side of the equation, you always put the inverse first or on the left. And that does matter because matrix multiplication is not commutative. So please remember, before you begin multiplying, that the inverse matrix that you come up with will be to the left, or it will come first. Then you will multiply times the existing matrix in the equation. It will always be to the right. Okay, well, we have a couple of 2 by 2 matrices, and this is now going to be a review of yesterday's lesson on how to multiply 2 matrices together. Remember, it's